Hi there! This is Karen Nistor and I'm going to talk about comparing values in Swift. In this video tutorial, I'll introduce two protocols provided by Swift: Equatable for testing equality and Comparable for comparing values. To compare instances of a custom type, the type must conform to these protocols. I show you how to do that using live Swift coding. We'll gradually enhance a custom type which represents a 3D vector so that we can compare two distinct values. Let's inspect the Gradable Protocol first. It declares a single static function which takes as arguments two instances of the conforming type. The function returns a Boolean value which indicates whether the values are equal or not. The Comparable Protocol specifies the less than, greater, and greater than operators. However, you don't have to implement all of them to provide the required functionality, as we'll see in a moment. Alright, let's switch to Xcode. I created a Swift playground for this demo. First, I declare a vector3 struct. Let's keep it simple. I'll only add three properties of type float representing the coordinates. There will be cases when we want to check whether two vectors are equal. If I want to do that now, I get a compiler warning. This is when we need the Equatable protocol. The vector type must conform to the Equatable protocol. Now the compiler complains about the missing equal to function. Two vectors are equal if their coordinates are equal. The implementation is straightforward. I compare the x, y, and z coordinates of both instances. If they are all equal, the vectors are equal. Now, what if we want to compare two vectors? We need to make our vector type conform to the Comparable protocol. The Comparable protocol inherits from Equatable. This means that if a type conforms to the Comparable protocol, it must also conform to the Equatable protocol. So I can safely eliminate the explicit conformance to the Equatable protocol from our vector3 struct. Now let's implement the Comparable protocol. We compare the vectors by comparing their length. Normally you won't do that, but it's okay for this example. So I implement the length method next. The length of a vector is the square root of the sum of the squares of its coordinates. Alright, now we have the length, so I can implement the less than operator. I instantiate a new vector. Let's see whether v3 is less than v2. What if I try to use the greater than operator? Surprisingly, this works too. Although I haven't implemented the greater operator, we get it for free. Actually, once we implement the equal to and less than operator, we get all the other operators for free. The standard library provides default implementations for all the remaining operators declared in the Equatable and Comparable protocol based on the less than and the equal to operators. That's it for today. But wait, there's actually more. Check out the other Swift programming tutorials on my channel. And please subscribe if you haven't done so already. Thank you and see you soon.